everyone, this is Dr. Esperanza and welcome to my calculus class. And for today we're going to be working on the derivative rules and how to use the derivative rules correctly. So we're going to be seeing the power rule, we're going to see the quotient rule and the trig functions and how to find its derivative in today's workshop. And today is going to be a little bit special because you're going to be sitting in my classroom with my student here in Barstow Community College. So stick around and let's learn the derivative rules. As I've mentioned, every time you are working on a derivative rule, this one, e to the square root of x, its derivative according to the formula is e to the u times du. So write down the formula so that you would know what your goal is. And the goal is to produce an equation like this. The only thing that you need to do is figure out what u is, figure out what du is. Now, finding u is always easy. It's just the given expression, which is square root of x. Taking the du will be something else because you need to take the derivative of square root of x. And we know that the square root of x can be modified into x to the 1/2. So to find its derivative, what is the power rule? You bring down the exponent and you subtract 1 from the exponent. 1/2 x 1/2 minus 2 over 2, right? So by simplifying this, we'll be able to find the du. And what is the du now? 1/2 x to the negative 1/2. And we're finished. However, we can make it prettier. Right? How are we going to make it prettier? Make the exponent positive and change it back to radical. Right? So how are you going to change x to the negative 1/2 into a positive exponent? Yes. Flip it and put it in the denominator. It's going to turn into 1 over x to the 1/2, right? And what is x to the 1/2? Radical x. There. Can you still make it prettier? Yes. And that is your du. So now that you have all the ingredients you need to find the derivative of e to the square root of x, which is your u and your du, just plug it back in and you're done. You'll have e to the square root of x times 1 all over 2 square root of x. Can you still make it prettier? Remember, this is over 1 and this is 1 over this. So if we combine this, you have that. So that is how you work out and use your formula. Write the u, find the du, and then put them back together just like what the instruction is asking you to do. So the challenge here is this. Taking the derivative of function. So you need to practice, you need to make sure that you have differentiated a lot of function so that this will come a lot easier. So in this f of x, boom, boom, they're the same. Okay? So there are a lot of functions that we can use to work on this problem. We'll have more of these examples later on because we have this. Copy it first. And I'll show you a technique that you can use every time you see an expression like this. Separating the constant with the function. Your constant is negative 5 and your function is e to the 3x squared. This particular rule is what we call as the constant multiple rule. That if we have g of x, which is equal to c times f of x, in this case c is negative 5, f of x is e to the 3x squared, you can find its derivative by setting aside the constant and just focusing on finding the derivative of the function. And in this case, you're just going to focus on this. So now it's becoming more manageable to differentiate because you will just set this aside and leave it for a while and focus your attention in finding the derivative of e to the 3x squared. Can you now find the derivative of that function? According to the formula, it's e to the u times du. And if you need to know more about the derivative rules, just click on this button right here and I have more examples on how to use those derivative rules that we're working on today. So according to the formula, I'm going to need my u and I'm going to need my du. What is u? What is the derivative of 3x squared? 6x. Now that we have all the ingredients we need, just replace this and that with those and we're done. We have e to the 3x squared times, am I forgetting anything with my answer? The constant. Don't forget it. You're going to set it aside, but don't forget the constant. So just bring them into the mix. And this is now your f prime of x. Can we make it prettier? Yes. How are we going to make it prettier? Combine these two and we'll write it as negative 30x e to the 3x squared. That is the standard form of writing out your function. Polynomial and then the natural logarithm or natural number. Okay? So that is your derivative. Negative 30x e to the 3x squared. Oh, so good. So trust the process. And again, the process is to always write the formula so that you will have a goal. When you know where you're going, it's a lot easier to master the derivative rules. I know it looks tedious. I know that we can cut steps. But the more that we will cut steps at the very beginning, the more that you will get lost on the process of the derivative rules. So as much as possible, master the rule first and make sure that you're understanding why it's written like this before you can skip a step. Because if I'm going to just answer this, I can do it in my head. But that's because I've been doing this for 18 years now. So I can take a shortcut. But for you, no excuses. You are still mastering the skill, so master it accordingly. Take the derivative of this function. So f of x, I can modify this by distributing it to here so that I'll have 2x squared plus 2x, right? I did not do any I did not do any calculus rule yet. That's why it's still an f of x. But once I start changing my notation from f of x to f prime of x, I'm going to take the ddx of 2x squared and the ddx of 2x. And the ddx of this one is 4x, and the ddx of the second term is 2. And since it's all addition, that is my f prime of x. 4x plus 2. So again, algebra will be playing a vital role in your quest in mastering derivative rules. Always simplify the expressions or equation or your function by combining like terms, using the law of exponents, or factoring. Whatever works. How are you going to differentiate 2 all over x? And again, my clue is you're just going to be using the power rule. So step 1 is algebra, step 2 is calculus. Because I am confident that you can work and use your calculus step. I'm just a little bit worried about your algebra step. Alright, to help you out, I'll use algebra, so it's still f of x, because I'm not going to do any calculus steps yet. How am I going to use algebra? I will change this into a negative exponent, because 2 all over x can be modified into 2x to the negative 1. And now, can I use my power rule now? Yeah. And do you think you can use your power rule now? Okay. So now, you can do f prime of x, because now you can take the derivative of 2x to the negative 1. And to do that, to bring down exponent, minus 1 in your exponent. And you'll have, and that is your f prime of x. Can I make it pretty? How am I going to make it pretty? Changing it back to a positive exponent. And how am I going to change x to the negative 2 in a positive exponent? It will turn into 1 over x squared. So, negative 2 times 1 over x squared is equal to negative 2 x squared. And that is your derivative. Again, use algebra so you can use your calculus rule. That is why, if you think I'm joking about mastering your algebra rule, I am not, because that is part of your calculus work. Without your algebra rule, this will be a little bit difficult to solve. So it's negative 2 to the x, negative 2 all over x squared. Oh, 3x all over 5. How are you going to differentiate this basic function in calculus? Okay, were you able to modify it? Yes or no? Be honest. No? No. I'll help you out. Algebra, which means it's still f of x equal to something. 3x all over 5 can be modified into your constant is a fraction. 3 over 5. Now, can you find f prime of x now? Of course. What is f prime of x? Yes. 3 over 5. So every time you are seeing a fraction which you can modify it so you can use your calculus rule. So 3 over 5. All about algebra. So this is the best time for you to get acquainted with all these crazy functions that you can work on using algebra. Okay, give me the derivative of this. So what is it? You cannot just write nothing. F prime of x is nothing.
0.
It's equal to 0. Why? Because this is a constant. E raised to 13 is equal to a constant. And any constant, f prime of x of the ddx of any constant is equal to 0. And this is clearly a constant. But for untrained eyes, they will think that it is e to the x. No, this is not e to the u du dx. This is just a constant. So that's why f prime of x is 0. Because derivative of any constant will be equal to 0. And if you use the e to the u du dx, it's still going to be 0 because the du of 13 is 0, right? And if you multiply it with e to the 13, it's 0. So to cut the process, know your constant so you would know your value. How about this? First, do you know the value of an e?
No.
Oh my god. Get your calculator. Push e, the letter e, and give me the value of e. What is e? E is a constant in mathematics. We call it natural number. And what is the value of the natural number in mathematics?
7182818.
So, loosely, 2.7. Every time you see an e, it's equal to 2.7. That's why the derivative of 2.7 raised to 13 is 0 because it's a constant. Now do you understanding what I'm speaking about e? You're not finished yet? What is f prime of x?
0.
And you solve for it?
Could be 2 pi now.
What is the value of a pi?
Oh, never mind. It's because I thought when you took the constant out.
If it has been 2 pi x e to the negative 8, then we're talking a different language now.
Okay.
Do you know how to find the derivative of this? What is the derivative? Is this a constant?
Yes.
Is this a constant?
Yes.
Is this a constant?
Yes.
No.
Wait, no. Wait,
X. Is this a constant?
Yes. Yeah.
We'll use the constant rule. We are going to set all the constant aside and take the derivative of x so we can find f prime of x. What's the derivative of x?
Just one.
Just one. For today, it's all about knowing your function, understanding your function, and knowing how to use the power rule in your function. So this will still be equal to 0. Okay, I will leave that to you. Make sure you use your notes, practice, because now we're going to move on to derivative of a trig function. And the derivative of a trig function has its own set of rules, because again, derivative rules are shortcuts. Every function has its own rule. So this is a family of function that has a different set of derivative rules. So power rule is no longer into play. And again, this is Dr. Esperanza, and thank you for spending your time with me learning calculus. And if you happen to like this video, please like, share, and subscribe to my channel. And if you happen to know anyone who is struggling in mathematics, please share this and tell them that they can watch my videos from algebra all the way to college level calculus in my YouTube channel. Thank you, and see you again next time. Bye! Sort of. This is how you take the derivative of sine u, or sine of a function. It will equal to cosine u